Okay, so I'm going to talk about the intrinsic conduction system of the heart. Okay, so the cardiac pacemaker cells pass impulses in a very particular way across the heart, and that's basically what this intrinsic conduction system. This is from our pacemaker cells, and this is basically how their impulse travels across our heart anatomically. And so we start with the SA node. So this is the SA node right here, and that is going to produce about 75 beats per minute. So just the SA node alone is about 75 beats per minute. This is the quote pacemaker of the heart, and it sits in the right atrial wall. And then that's our step one. So I labeled that up here. That's our step one. We start at our SA node always. Then we run through these little fibers right here that I highlighted. And these are going to actually run into both of our atria. So we have our right atrium and our left atrium, and these innervate both. But we're just going to focus on them connecting the SA to the AV node. So that's their main purpose. So the junctional fibers, they're just like a little highway system that run from SA to AV. They're just sending a message from here to here. So that's our step two, and then we're going to run into step three, which is going to be our AV node. Our AV node, right here, I went ahead and labeled that right here as step number three. Essentially, this guy delays the impulse from the SA node by approximately 0.1 seconds. And this is because he's kind of a little smaller. His fibers are smaller in diameter, and there's fewer gap junctions. So this is like the king. This is just a little second messenger kind of guy. He's a little not as complex as our SA node. And so he's delaying this impulse by about 0.1 seconds. This allows atrial contraction prior to ventricular contraction. So if we didn't have this AV node to delay, we might have an issue where our heart is contracting our atria at the same time as our ventricles, and that would be very bad and very inefficient. And so we need this guy to delay the impulse so that these atria will contract before the ventricles contract. So that's his main job. And if the SA node were to fail, we know that the AV node can take over and produce about 50 beats per minute. So I went and highlighted that right here. If our SA node fails, our AV node can work at about 50 beats per minute. And so that's good to know. And then we run into step number 4. Right here. I lost my writing. So step number 4, we get into our AV bundle. It's also called the bundle of His, and I went ahead and labeled that right here. It's kind of weird on my drawing, but basically what the bundle of His is, it's this cord before it branches. That's kind of what it is. So it's a cord, and it hasn't branched just yet, and so the AV bundle works at about 30 beats per minute. So if the SA and AV node fail, we can actually still work at about 30 beats per minute with just this AV bundle. It's the only electrical connection between the atria and the ventricles, because it's right here. This is our atria, these are ventricles, so it's right between. It's our only connection. And so it transmits impulses to the right and left bundle branches, which is going to be our step 5. So we're getting to step 5, these guys, and that's going to be these two highlighted in yellow areas. Those are our left and right bundle branches. Basically, just another little highway system that we have. The right and left bundle branches carry impulses to the walls of the ventricles. So since these are our ventricles, these will be our walls of our ventricles. So they're innervating the muscle here. And these are going to carry impulses toward the apex of the heart. And once we get to the apex, these branches turn into something else, and that is going to be our step number 6. Those are called our Purkinje fibers. So highlighted in blue our Purkinje fibers, and those go all the way on the outside of the heart around our ventricles. So those complete the pathway through the interventricular septum, which is this whole area is an interventricular septum, and they go from the apex all the way around the ventricular walls, the outer ventricular walls, and they're innervating all that muscle right there to send impulses. And so the Purkinje fibers would also run at about 30 beats per minute. So I wrote that here as well. And that's the same rate as our bundle of His. The Purkinje fibers cause contraction starting at the apex that continues toward the atria, but it's really just ventricular contraction because we're not reaching up here. This is just responsible for our ventricular contraction. And then that's basically the whole process. We went from sinoatrial node down our junctional fibers, and we went to our AV node, which is right here, AV node. Then we went from our AV node to our AV bundle or bundle of His. Then we traveled down 2 branches, the right and the left, and those will turn into our Purkinje fibers and wrap around the ventricles on the outside. And this entire process from start to finish takes about 0.22 seconds, which is very fast. And once you hit the end of this, it just restarts at the SA node. That's our pacemaker. So it's going to start the process all over again. And yeah, that's all I have for the intrinsic conduction system.